so this leads us into our next topic, which is algebra.
Oh boy.
So what I wanted to know with this is, I wanted to know whether you already would immediately start using algebra or not, which I think was a not.
Yeah.
All right. And then I wanted to see how you went about doing it, whether you had a trial and error method or whether you had a more structured approach. And these problems are good in the fact that they are a language, and I want you to think of maths as a language, and therefore algebra just follows the rules of that language. Okay? And this is a good way, so this is written in English, but what we're going to look to do is write it using mathematical notation, using algebra, but understanding that algebra is representative of a language. Yeah? Does that make sense to you? So, I did hear Tiaja say about, you just go backwards.
Hey, I said that.
I didn't hear it, I heard it. If you did say it, that's great. I'm not saying you didn't, I just said I heard Tiaja say it.
I said
Okay, so, thing is, what we've got is Maria thinks of a number, okay? So, she thinks of a number, whatever that number is, right? And then
X.
she doubles her number. So doubling her number means the first thing that she does to her number is times is by 2. Okay? So there's her first mathematical operation. Okay? By the way, don't write these as notes yet because you're going to write them in your notes book. Right? So just work with me, listen to me. Right? What does she do? So we get a result. We don't know what that result is, but she takes that result and does what?
Adds 3.
Adds 3. So she adds 3. She does another operation. Come on,
Can I tell you what I
add 3. Right? She gets an answer, and we're told the answer this time is 37. So here's the thing. What we then do, when you say we work backwards, it makes sense that we do undo what has been done to try and get back to where we started. And that is the whole thing that we need to try and remember with algebra. Okay? Lots of people when they do algebra think moving things around and changing signs and all that kind of stuff. And I like to avoid thinking of it that way because that's like a shortcut method. What I'm trying to get you to think about is you are going to undo what has been done. You're going to try and find out what the answers were before something else happened. So for instance, to get back to the first question mark, I kind of need to know what the second question mark was. And how do we do that?
Well, what I did was I took 37 away from 3.
No, you didn't.
I did.
No, you
3
didn't.
away from 77.
You took 3 away from... Because if we've got something and we add 3 and get the answer 37, it makes sense that if we start with 37, we have to subtract that 3. So we take 3 from 37.
Oh, okay.
Yeah, not 37 from 3. So we have to take the 3 away. That tells me what the question mark was, which was 34. Okay? That tells me the first question mark. Then, the next thing we have to do, well, if that number was times by 2 to get that one, we have to reverse that and do divide by 2. And we get the answer 17. So we know that Maria was thinking of the answer 17. Now this is called, right, using inverse operations. Do you know what I mean by that?
So you're using it like backwards instead
Yeah,
of
so the inverse of adding 3 is subtracting 3. The inverse of timesing by 2 is dividing by 2. But what we've also had to do, take note, okay, is do in the reverse order as well. Because if I did it in the wrong order, I would get a wrong answer out. Does that make sense? Yes. Do you want to write that bit out now?
Yes.
In the front of your book, give yourself a title of Algebra, and you can write that.
Wait, are you going to give us your test back?
Maybe not.
So one other thing just to mention here, what I've drawn, this would be an example of a flow diagram, or you might recognise it as function machines. So something goes in, here are the functions that are applied, times 2, then a plus 3, and the output is the 37. So you may well have seen that before, right? So that's one way of writing it. However, we do have a much better way of writing these things now, don't we? We're going to use algebra, right? So we don't want to use all our space writing all these flow machines. We want to use algebraic ways of writing. So I think your first step was to say, well, instead of question mark, I would rather put what?
X.
An X. You can use an X if you like. You can actually use any letter you like.
I used
N, yeah, N for number. There are some things that we should take into consider, like if I'm going to eventually draw the graph of the function, normally it's X's and Y's. If I'm doing a sequence of numbers and I'm looking at patterns in numbers, I usually use N. Okay? And if I'm doing something with science and I've got a function or equation, I might use the letters that are involved. That's speed or distance or time. So it's not always X, it's not always N. We pick the letter that's most appropriate. But in this case, we would start, instead of the question mark, I'd put an X. Now we've obviously got to find a better way. We can't just write X and then still do the arrows and the function machines. So we have to write it correctly. What I want you to think about here is when I look at an algebraic equation, I need to be able to understand what it's telling me, the language. So, what do we do to X? What's the first thing we do to X? Times by 2. So, I could write times by 2, but we don't do that, do we? We don't. We do 2x. We don't do x2, we always put the number first. So 2x means 2 times x. Alright? And then we have to add 3. Now this, on its own, before I decide an answer, is actually called, does anyone know? This is an expression. So that's the expression. But once I give an expression a value by saying that is got to equal, in this case, 37, then it makes it an equation. So an equation is an expression with a value. Does that make sense to you? Yeah? So sometimes you're asked to write an expression for an exam, for instance, if it says write an expression, you shouldn't really have any equal sign in there. So the equation means you have an equals. Yeah. So what we ought to be able to do, which what I would like you to be able to do, is to read the equation in this way and then think, how do I go backwards? So I don't look at this and go 2x plus 3. I look at it as, think of a number, or there is a number. If I double it, then add 3, I get 37. That helps me think, how do I find that number? Does that make sense? We're trying to think of that as a language and not just a load of numbers and letters. So, should we have a look at the next one? We're not going to solve it yet. We'll go through the answers. We'll do it afterwards because I want to look at how you go about solving them. Right, Marissa thinks of a number. What should we call her number? Why not? Should we call it M? What does she do? Adds 2. So I just write M plus 2. Okay, divide by 2. So you might think we would do that, but we don't, do we? How do we improve on that?
Put in a bracket you n plus 2 over 2.
Okay, so we can put a line and put all divided by 2. Now if we've got a line that goes under everything, we don't actually need the brackets. You can have the brackets if you want, but we don't need them, because that line means everything is divided by 2. You've got to be careful though, because if I were to write n like that, that means something different. That means that Marissa did the divide by 2 first, and she didn't do that. So this is not right, so we've got this. So that's my what?
Your expression.
Good, that's my expression. And then she says the answer is 8, and turns it into an equation. Okay. So we've got m plus 2 over 2 equals 8. Right. What about Mariah? Can we think of a letter for Mariah?
A.
A, okay? Let's use A for Mariah.
Wait, but how do you
all vary.
Well, we'll solve it in a minute.
Oh.
I'm just going to write the expressions and the equations. So what should we do? I multiply by number by 6 and add 5. So what do we write?
6a
So 6a
plus 5
plus 5. That's my
Equation. I mean, your
expression.
And then equals 47. which
Turns
is
it
your
into my
equation.
equation. Okay? Now this is a trickier one.
Wait, so would you do like 3r?
Do you want R?
Sure.
Alright, R,
So we do 3r,
3R,
take away 2,
take away 2.
and then multiply. No, would it be 4r times 4r?
Well, what do? We have to
Divide.
multiply all of that result by 4.
Yeah.
How do we do that?
Put that
so
in brackets.
Brackets?
So we have to
Yeah.
put that in brackets,
Oh,
and then
The 4 on the
times
outside.
and the 4
Oh!
goes there.
That's how it. Oh, okay.
Yeah, makes sense? So it means we have to do R times 3, then we subtract 2, then we multiply everything by 4.
Wait,
So
what's,
again, I want you to be able to read that and know exactly what it's telling you. Yeah? It's like learning a language, a written language in Spanish or something.
And then
Subtract that first.
So we have to do the subtract 2 first. Yeah?
and then brackets first. Wait, so you do
Oh,
it.
So that's my expression, but
Oh,
my
I think I can-
equation, what do I write? So the answer is 5 less than 153. How do I write that?
So take away 5.
153, take away 5. Okay?
oh,
So I've written all my equations out. Does that make sense? So what I want you to be able to do is when we look at things, especially like this one on the board, I want you to be able to read that to me and not just say 3r minus 2 brackets 4 equals. I want you to say, well, r is multiplied by 3, then subtract 2, then we multiply that result by 4, and I get the answer, whatever I get the answer. Okay? That's what I want you to be able to tell me. Because of course, what we then do, if we want to find the answers out, well, this one we've got the answer 17 because we've done the reverse. What we would like to be able to do is do the same with the algebra. So what I'm going to do, let's go through these. So I've got to rewrite mine. So what was the first one?
the first
2x
one,
plus
2x plus 3 equals
equals
37.
37. So if you think about how we would go about doing it, how would you go about finding that number. So what we are doing here is we are doing solve for x. And what that means is find the x.
Okay.
So I would like to know your methods for solving for the x. Try, go on.
Well, I don't know, but I mean, like, so would you do like 2 divided by x, take away 3?
Well, let me think about that.
Remember
Does
our
that
teacher told us-
make sense with what you are doing when you read it in language? So when it was before,
Because we have to get rid of the x.
we don't.
Well,
We want to know the x at the end.
well, we have to get rid of the other number.
We have to get rid of the other numbers. But if you think about it, remember, if we go right back to the beginning,
Remember Miss Harrison telling us?
Yeah, that's what I was
Right.
thinking of.
remember here, you've got to do the opposite things in the opposite order. Right? So, if we go back to here, we've got to do it. This says x was multiplied by 2, then we added 3, and we get the answer 37.
Yeah,
So we've got to undo the things that have been done. So the first thing is,
36 minus 3.
okay, so there are lots of ways to write this out. What I would do, this is the way I think about it. So if we've got, there are 2 times x, then I add 3 and I get 37. So because I know how to read it, I will then know that, well, I've got to subtract that 3 to get rid of it. But that will also mean that the answer is 3 times smaller. So I've done it to both sides.
Yes,
That's where I remember it from.
So I end up with, well, if I don't have the plus 3 anymore, I'm left with only 2x
x equals
equals
37.
34.
Oh.
Because the 37, if I take 3 away from one side, I have to take it away from the answer I was getting as well.
Oh, and
I
then you
remember
do
Miss
34
Harrison
divided by 2.
So now I have to divide by 2. So if I do my divide by 2 like that, so if I divide that by 2, I have to do the answer divided by 2.
Oh yes, I remember.
And I
so
get
then
x
you would just keep
equals-
the x alone. That's how you get the x alone.
Exactly.
Oh, yeah.
Now, so we get the x alone by undoing the things that were done to it.
But we do it in a more sophisticated way.
No, that's fine. I think we're just reminding you. Quite often what people try and do is they kind of move the numbers around and swap sides and things like that. I don't want you to think like that, which I think you're doing really well. You are thinking, I'm undoing the things that have been done. That is the perfect way of thinking about it. Alright? But the thing is, you have to be able to read the first equation and understand the order in which things are happening. Yeah? Should we have a look at the next one then?
Yeah.
So the next one is n plus 2. Right? n plus 2 over 2 equals 8. So again,
Oh, so would
we
you-
have to think about the order in which it happens and what happens. So
Okay.
the last thing that was done is,
Division.
It was
so the last thing that
divided by
happened was
2.
multiplication.
okay, so the last thing that happened is division. So the first thing to
that
do
we
going
did
back
is
is
multiplication.
multiplication. So we divided by 2, so we have to times by 2.
Yeah.
So I have to do it that side too.
Times
So I'm left with, that gets rid of my divide by 2. So I'm left with m plus 2 equals 16.
So
Okay.
then it would be, since it's a plus, it would be a minus. So that's 16 minus 2, and then do it to the other side.
14.
And then that would be m
14.
equals 14.
Exactly.
Yeah.
Now, can you see how, if I didn't read it properly,
Wait,
I might try and subtract 2 first.
yeah, that's right.
Yeah. See, this is the thing. Can you see, if I did in the wrong order, so I'll write this now, in the wrong
So we need to
order.
make sure that we read the question.
Exactly.
Yeah.
So if I did m, come on computer. M plus 2 divided by 2. Now if I decided to do it differently and did maybe subtract 2 first, because I'm doing it wrong, that would leave me with m over 2 equals
4,
6.
6.
Yeah? And then you would times by 2, and you would end up with m equals 12, which looks fine, doesn't it?
Yeah,
But you know it's wrong because you've done it in the wrong order. And I can check it by doing, well, 12 add 2 is 14, divide by 2 is 7, but I need 8, so I must have done something wrong.
Yeah.
So this one here is definitely
That's
in
how you
the...
check the answer.
That's how you check your answer, exactly. So this one's in the wrong order here, so we have to be very careful about that. Alright?
Good.
So that's why it's very important that you think of what it says in the language. We ready for the next one?
Yeah.
So what do we have? 6a plus 5 is 47. Right. So we've
Okay,
got
the first thing we
6a
should do
plus 5
Equals
equals...
47.
So does everyone know the last thing that was done to get to the answer 47?
Subtract.
What was the last thing that was done?
5.
Plus 5. So the thing we've got to do first is...
Subtract 5.
So if we subtract the 5,
And then subtract 5 from 47.
so 6a equals
42.
42. And then we...
And then you
Then you divide by
you
6.
divide 6 by 6, and then 42 divided by 6 equals 7.
So we've got a equals 7. Alright? And finally, we've got the hard one. So we've got
4 bracket 3 r minus 2.
and what was it again? 100 and...
It's plus 2.
It was plus 2, is it?
Yeah.
No, it's take away.
No, it's plus.
It's take
Minus
It's takeaway.
oh. Equals 1,
Wait.
5, 3 minus 5.
1, 5, 3 minus 5.
Wait,
Okay.
so since you do the brackets first, would you like...
There are a couple of ways to do this, actually.
Wait, should we minus the 5 at the end?
Well, actually, should we do that first?
Yeah.
Okay.
So we can make that simple first, don't we? What's 153 minus the 5? Let's just do that first. So 148. So we've simplified a little bit. Okay, we've done what we can. Now there are different ways to do this.
You can
Wait.
You could time. It's always 4 times what's inside the bracket. So like 4 times 3 is 12, but you add r. So it would be 12r.
Only 12R?
12r take away 8.
Okay, so there are two methods here. I'm going to go over here and do what Taylor is explaining. Do you remember expand the brackets?
Yes.
I don't know whether you call it fireworks or eyebrows or whatever. So we can do.
Smiley face.
So we've got
That
4
was cool.
lots of 3r minus 2 is 148. So we can expand the brackets by, if I've got 4 lots of 3r minus 2, that's the same thing as 4 times 3r is 12r, and 4 lots of minus 2 is minus 8.
Yes, yeah. What?
Yeah, I
Okay.
remember. Oh,
Do you
yeah.
remember doing that?
Yeah.
So that's just like, well, if I've got 3r and minus 2, if I do that 4 times, I've got 12 r's and I've got minus 8.
Yeah, that makes it easier.
Well, it could make it easier,
But
not
would it-
necessarily.
Right?
But we'll do it this way first.
Wait, no.
So
So
then
what do we do now?
negative 8.
So now, let's read it again. We've got a slightly different problem.
We add 8.
Okay, so can you read that to me first? I start with a number and I do what now?
Add. Wait.
Read it to me. Start with a number
Then
12R.
Then you times by 12.
Times by 12.
And then minus 8.
Then subtract 8, and I get the answer
114.
148. So I'm doing something different now. I will get the same answer. So what do I have to do first?
Plus 8.
Plus 8.
Equals 0.
So plus 8 there. So that gives me 12R equals 156.
6, yeah. And then
And then
divide it by 12.
divide it by 12. Gives you 1R would equal 156 divided by 12.
Oh, I don't know this.
12 is 144, so.
I know.
I don't know.
I'm thinking.
12 12s are 144.
It's 13.
Add another
156.
12, so it's 13.
Oh, whoops. That's what I was thinking.
Good.
I was thinking.
I can't really confirm that, but if that was what you were thinking, that's good. Right, are you okay with that?
Yeah.
Now, can I just show you though that we could have done what we've been doing before. Instead of expanding the brackets, let's just go from what we were doing before and just doing the opposite of what happened. So for instance, I've got R times 3, then minus 2, then times 4 equals 148. So what was the last thing that was done? No, what was the last thing that was done?
Take away.
Subtract.
No.
Times
Multiply by
3.
4. The times by 4 was the last thing to be done, yeah? So the first thing to be undone is the
Dividing by
times by 4, and we do it by dividing by 4. So let's divide it all by 4, right? Leaves me with just 3R minus 2, and 148 divided by 4 is?
I don't know.
Let me think.
Yeah, one.
You can use a calculation if you
I do.
wish.
Wait a minute. I think I put it in the.
I would just do 14 divided by 4.
I think it was 27
Is it 27?
or 37.
37.
37.
Yeah, 37.
Right? So I've got 3R minus 2 before I times by 4 had to equal 37.
So then you do plus 2.
Then I can add the 2. Gives me 3R equals
3R equals
39.
9.
39, yeah.
And
Then you
divide
by
3.
divide by 3. Gives me 1R has to equal, well, it needs to be the same answer as over here, really. Does it? Is it 13? 3 lots of 13, it's 39, isn't it?
Yeah.
So we get the same answer, which is lucky, because if we got a different answer, we've done something wrong.
all over again.
Okay. That makes sense.
Yeah.
Okay, so what we've got to be able to do though is with algebra, we've got to think of it as a language, but there are some things that we can do to simplify stuff. Right, we can collect. Have you ever heard of collecting like terms before?
Yes!
Yeah, collected like terms
Yeah.
to simplify things together.
Yeah.
Right? And we want to be able to simplify so that when we do this solving, it's easier to do. Right? So we need to check that you're able to do that. So, can you get your textbooks? Yours. And turn to page
Wait, we only have 5
78.
minutes left.
Well, I want to show you now. Turn to page 78.